So today, I wanted 2 days for review. We have a test on Friday. We have 3 sections left, so that means we have to do a section and a half a day. Guess what the sections are?
Easy.
Super simple. They're super easy. All right. Again, to me, this whole chapter is super easy. It's just about knowing the rules. All right. So with that in mind, all right. We have 6.4, 6.5, and 6.6. I'm just gonna, I put them all on one worksheet. All right. So we could just kind of take our time, scroll through, get what we can done. And then our review will be on Wednesday, and our test on this chapter will be on Friday. All right. And guys, you know, I don't think I've been as strict with the masks, but people are, you know, there's a lot going on. So just please make sure, I don't want to be fussing. All right. Just make sure you got your mask on and keep it on. All right. So with that being said, we want today to start with parallelograms. All right. And special parallelograms. And today, the first one we're going to talk about is a rectangle. So is a rectangle a parallelogram? So everything we know about a parallelogram applies to a what? Applies to a rectangle. Now, why is a parallelogram called, or why is a rectangle a special parallelogram? All of the angles are 90.
Angles are right angles.
Yeah, that's exactly correct. All of the angles are 90 degrees. All right, all of the angles are 90 degrees. All right, so again, it shares all the characteristics. So what does that mean? That means that we know that AB is equal to DC. We know that BC is equal to AD. We know that the diagonals bisect each other. All right, so this is equal to this, and this is equal to this. However, what do we know about the diagonals of a rectangle? They are definitely equal, or they are congruent. All right. So again, let's just show why they are congruent. All right. Let's prove they are congruent real quick. All right. We don't have to write the proof. We just want to show you. And this is what I'm talking about when I say I don't have everything memorized. To me, there's no reason to memorize everything if you understand the principles of a parallelogram. All right. Now, if angle A is a right angle, and we know that angle B is a right angle, then how do I show that the diagonals are congruent? How do I show that the diagonals are congruent? Someone tell me. Go ahead, Mr. Stauffer, you're good at this. No, come on. So tell me about this triangle right here. So if I say A, B, D, and now I'm going to move that. What? If I move that over here, all right, that's ABD. All right, now what I'm going to do is I'm going to drag the other triangle, which is this triangle right here. And again, part of the reason why I feel like this is harder is because the triangles overlap. So now if you just drag that over here, someone tell me what's true about that. Come on, Morty, go. How do I know that AC is congruent to BD? That's essentially what we're talking about. It's so simple. Go, William.
Because the triangles are congruent by side and side.
Exactly. Come on, that's super easy, right? It's not easy when they're overlapping to see that, but you should be able to say, okay, AD, come on, everybody say AD is congruent to BC, AD is congruent to AB, and then angle A is congruent to angle B, so the triangles are congruent by side angle side. Therefore, AC is congruent to BD. So we just proved that the diagonals are congruent. Does everybody agree with that? All right, look how simple that is. All right. Now, because the diagonals are congruent, what's true about AE, EC, EB, and ED? They are all equal. All right, they're all equal. All right. If AC is congruent to BD and they bisect each other, that means all of those pieces are equal. Is everybody okay with that? All right. And essentially, that's it. All right. That's what makes the rectangle special. All right. So let's knock this out real quick. All right. And once again, guys, I don't care so much about the algebra because I think the algebra is too easy. But we have to write the relationship. What's true about AC and BD? So what equation are we writing? 2x plus 13 is equal to 4x minus 1. All right, so let's practice the mental math today. All right.
Sorry, I couldn't quite hear you. Could you please repeat what you said?
Thank you, Siri. All right. So if we do the mental math here, x is equal to what?
7.
6 or 7?
7.
Well, I'm glad we're practicing.
Oh, wait, no,
It's 7. No big deal. X equals 7. All right. Now it says find dB. All right. So then dP is what?
27.
Now that's on the test, okay? You're going to solve for x, and sometimes it's going to say x, and sometimes it's going to say dB. And then if you just put x and you circle x if it's multiple choice, that's the problem. All right, so make sure you're careful with that. All right, so now number 2 is the same. What about number 3, AE and EC? What's true about AE and EC? They're equal. So 3x plus 3 is equal to 5x minus 15. All right, let's use our mental math here.
9.
Yes, thank you.
Oh, yeah, 9.
9, right? X equals 9. So now we're finding AC. Somebody said how much?
30.
Am I wrong? Somebody else, AC. Somebody help me. I think it's 60. All right, I think it's 60. If you said it was 30, this is what I'm trying to tell you now. When you take a test and everybody gets mad because their grade's a B and it should be an A because they answered the what? They answered the wrong question. It's asking for AC, right? You plugged it in here and you got 30, but that's AE, not AC. Does everybody agree? All right. So let's do number 5. Where's DAC? DAC is right here. And where is BAC? Right here. Are those equal, by the way?
No.
Definitely not. Or we did not say that the diagonals bisect, right? We do know, come on now, look up. This angle right here is equal to this angle right here. And this angle right here is definitely equal to this angle right here. But does everybody agree those angles are not equal to each other? All right, so be careful with that. But what's true about those two angles? Yes, they add up to 90. They add up to 90. All right, so let's add them up. What do we get? 5x plus 5 equals 90. So x plus 1 equals 18. So x equals what? 17. All right, so what are we looking for? BAC, right? So BAC is 52. Angle BAC equals 52 degrees. All right, I said I just don't think that's that hard. All right, I don't think it's hard. All right, let's try number 7. All right, let's look at ABD. Let me find ABD. ABD is this angle right here. And CDB. Oh, thank you. What was that, Sam? They are equal because they are alternate interior angles. All right. So thank you. 7x minus 31 equals 4x plus 5. So what do we have here, guys? I think x equals 12, right? So here we go. We want ABD. ABD, right? Somebody tell me. Angle ABD equals 53 degrees. All right, I'm happy with that. All right, let's see how hard this proof is. Given RSTV is a rectangle and U is the midpoint of VT, I want to prove that RUV is congruent to SUT. All right, here we go. This is simple, right? I want everybody to do this real quick, all right? I'm not gonna write everything down for you, all right? I want you to do it, all right? I'm gonna give you 2 minutes. Let's see how good you are, all right? See if you can write that proof out. All right, someone tell me about number 2. All right, Sam, tell me something. RV is equal to ST. I like it. Why is that? Right, I like that. Opposite sides of a parallelogram are congruent. Good job. Someone else step in. AC, go. Angle V. Now, why are they congruent? So let's say, yeah, I know. Don't be mad. Angle V and angle T are right angles. Does that make sense? You have to say they're right angles first. You agree with me? Right. So again, if you didn't write that down, I understand. And that's just definition of what? Definition of rectangle. And now your step is good. Angle V is congruent to angle T. All right angles are congruent. All right. So now I have this is this, this is this. Okay, someone else. Tell me. Yep, VU is congruent to UT, definition of midpoint. Okay. And tell me, Harris. Yes, side angle side. Now look, honestly, if you said that was simple, then you are in great shape. All right. I just think that's super easy. All right. There's no reason for anyone to have struggled with that whatsoever. Is that the only way to say it? No. Is that the only order you can put it in? No. So don't say I got it out of order, so it's wrong. It's not true at all. All right. The only thing that I would probably say is it's not the biggest deal in the world. But if you forgot that, I totally understand, because I probably would have forgotten it also. All right. So here we go. Now, here we're going to create a paper, right? And we're going to add a page, and then we're going to turn our page into graph paper. All right. And then we're going to plot these points. And then how do you think you determine using the slope if it's a rectangle? Who can tell me what you think? How do you know it's a rectangle by using the slopes? Come on, someone tell me.
If the two opposite sides have the same slope.
But how do you know that makes it a rectangle, though? Because all of the opposite sides of any parallelogram are going to be equal. Someone. Brady.
If like the opposite lines are perpendicular.
Yeah. If consecutive sides, you're comparing consecutive sides. If the consecutive sides slopes are perpendicular. All right, that's what we want to do. All right, so what I'm going to do is I'm just going to grab number 10 and put it down here, blow it up so we can see it real quick. All right. And let's graph this real quick. So -3, -2, -4, +2, 2, 4, 3, 0. So that looks like a rectangle. All right, so here we go. Now, all you have to do is say the slope of this. What's the slope of that? I like drawing it so you can just count it out. What is the slope of the right side? What is it? -4. Everybody okay with that? All right, I need the slope of the bottom side. Is that right? So is it a rectangle? No, it's not a rectangle. Right? That looks like a 90-degree angle, but it's not. So this is not a rectangle. Number 2 is not a rectangle, because again, these are consecutive sides here. All right, these are consecutive sides here and here. All right, so they are not a rectangle. Okay, what? Tell me. I can't hear you. The one on the right. Isn't that slope -4, or am I wrong? Because -4 and 1/3 are not negative reciprocals. This has to be what? What would this have to be down here? Yeah, it'd have to be 1/4. If that's 1/4, then they are perpendicular. You agree now, right? Okay, so now let's grab number 11. And we want to do distance formula, and I'll try to explain that. Is it good enough just to say that the opposite sides are equal? No, because all parallelogram opposite sides are equal. So what do you think they mean by distance? Angles are not a distance. What are they talking about here? Yes, the diagonals. If the diagonals are what? Yes, if the diagonals are equal. So here we go. Let's graph this real quick. 1, 2, 3, 4, 5, 6, 1, 2, 3. 0, 1. Does that look like a rectangle? Is that what everybody else is getting? Bless you. Okay, so here we go. Let's graph now this first diagonal. All right. Now again, remember what now remember what I tried to tell you was it's just Pythagorean theorem, right? All right, so let's look. I'm trying to make this the triangle, right? So here to here. All right. So this distance 1 is 4. Does everybody agree with that? And 1, 2, 3, 4, 5, 7, right? So diagonal 1 is equal to, someone tell me. Yes, 16 plus 49, which is square root of 65. All right, now I'm going to find diagonal 2. Here's diagonal 2. So from here to here. So what is that? 1 plus, yes, 8 squared is what? So that is, so is it a rectangle? Yes, it is a rectangle. And why is it a rectangle? Because the opposite sides are equal. Opposite sides are equal. As long as they, not the opposite sides, but the diagonals. As long as the diagonals are congruent, it automatically makes a what? It automatically makes a rectangle. Everybody good with that? Yeah, I don't think that's that bad. All right, here we go. All right, now let's do this. Yeah, I just don't think that's that hard. Everybody can do 6-4. All right, hold up. I may not assign all of it, but let's just get started on the next assignment. Let's do about half the next assignment. All right. Okay, so who wants to tell me what a rhombus is, or rhombi, which is just plural? What's a rhombus? Who can tell me what a rhombus is? Tell me, AC. Yes, it's a square that does not have what? Does not have right angles. So the rhombus and the square are related because the sides are congruent. Sides are congruent in a rhombus and a square. And everything about a parallelogram applies to the square and the rhombus. Does everybody agree? Except all 4 sides are now what? Congruent. The square, however, is a special rhombus because in a square, all of the angles are what? 9 degrees. Does everybody agree with that? All right. So now, what I want to do is I want to mark this. All right. Because this is a rhombus, this, those are all equal. Does everybody agree with that? Any questions with that? Now we also know that this is equal to this, and this is equal. So now someone tell me what's true about all of those triangles that are formed, those 4 triangles. They are all equal. That's what I'm trying to tell everybody. You just don't have to memorize all these rules. right? You can just look at it and say, okay, now, if all of those are equal, someone please tell me what's true about all four of these angles right there. They are all equal. So if they're all equal, what does that make true? No. Let's not think about the diagonals yet, but tell me what are the measure of those angles? They are all 90 degrees. You just told me they were all equal. So that forces them to be 90 degrees. So again, the diagonals of a rhombus are what to each other? They are perpendicular to each other. They are perpendicular and they bisect. All right, now again, I'm just piling up all the rules. But once again, I'm not memorizing the rules. I can just obviously figure that out. Now, someone said that the diagonals of a rhombus are congruent. Is that true or false? Yes, that is not true. That is false. If it was a square, the diagonals would be equal. All right, so I always tell kids just visualize as soon as you start tilting something, one diagonal gets what? Bigger and one gets what? Shorter. So the diagonals of a rectangle and a diagonal of a square are all equal. But the diagonals of a rectangle, or not a rectangle, but a parallelogram are not necessarily equal. All right. So I think those are the things that are important. All right. Now, what's true about if I wanted to look at this top rectangle or triangle and the bottom rectangle? Are those equal? Yes. All right. And if I wanted to look at this triangle and the bottom triangle, would those be equal? Yes. And then as well as all four what? Small triangles. Is everybody with me on that? Super duper easy. All right, but as I try to tell kids, there's so many rules for every different shape. You just cannot remember them all. Don't try to remember them all. Draw out the shape and see how simple it is to show. All right, so with that, that's the rhombus. All right, so here we go. I'm going to remove this now, and now we're going to talk about these problems. If dk is 8, KL is what? 8, obvious. If DML, angle DML is 82 degrees. So DML is 82 degrees. Then what is DK, what is DKM?
41.
Yes, 41 degrees. Very good. Anybody have any questions with that? Now, let me go back to that because I didn't do a very good job explaining that one. All right. I think I went too fast. So look right here, guys. This triangle up here is exactly the same as this triangle down here. Does everybody agree with this? Therefore, what is true about this and this? They are equal. All right. Now, what's true about this guy right here and this guy right here? These triangles, what is MDK called? What kind of triangle? It's called isosceles. That's why it's easy to see. This is equal to this, so that's an isosceles triangle, right? So now this MK, the diagonal, is called an angle bisector. So everybody agree with that? That's an angle bisector. That's how we knew that if this is 82 degrees, it's bisected to become 41. Bless you. All right, is everybody okay with that? All right, let's knock out number 3 now. All right, let's find KAL. How many degrees is KAL? 90. All right, so we just say 2x minus 8 equals 90 degrees. So x equals what?
49.
Thank you, 49. Beautiful. All right, number 4. I'm going to erase this again. All right, number 4, DA and AL. What's true about DA and AL? All right, they are equal. So what does X equal? X equals 3. And so what is DL? Somebody said 24. Now remember, if you're not sure about how we got 24, you can speak up. Anybody have any issues with how we got 24? All right, I'm pretty happy with that. If DA is 4X and AL, isn't that the same thing, right? Yeah, except we have to find AD. All right, which is the same. All right, you're right. Let's just set them equal to each other, and what do we get? X equals 3. So then DA is what? AD equals 12. Simple. All right, here we go. DM and DK, what's true? They're equal. So tell me what we got. 2y equals 4, so y equals 2. So now they're asking about KL. What's KL?
12.
12, thank you. It's 12, right? Because all sides are equal. All sides are equal. All right, I'm pretty happy with that. Let me see how much more. Okay. Let's go ahead with, let's just knock out this proof and then we'll be most of it done. All right, here we go. Let's knock out this proof real quick. All right, so given it's a parallelogram, we're trying to prove that it's a rectangle. And to me, the easiest way to prove it's a rectangle is to prove that the what? Yeah, but it would be hard to prove the lines are perpendicular if we don't know their slopes, right? So what is another way to prove that they are, or it's a rectangle? Yes, you have to prove the diagonals are equal. All right, you have to prove the diagonals are equal. So let's see what we got here. All right. Does it pretty much give it to you? All right, let's see. All right, come on, everybody try to write the proof. Yeah, this one's kind of annoying actually, but. All right, I think that's pretty good. All right, hopefully you did something similar to that maybe. Right, so let's look at that and make sure, a little trickier. So what I did was I knew the diagonals had to be equal. So I just labeled the diagonals. And the diagonals are Rx plus Xt equals Rt, and then Ux plus Xu, or plus Xx equals Us. Everybody okay with that? That's segment addition postulate. Now, what I did was I thought for a second, I'm trying to get the diagonals equal, right? So I know, now here's the tricky part. I know that Rx and Xt are the same as what? Ux and XS. So I just replace those. Did everybody agree with that? And that's by what? Substitution. So now I have this. Now, if you're a little confused, I understand. Now this right here is exactly the same as this right there. So because those are equal, then I knew that US was equal to RT. Anybody have an issue with that? And those are what now? Those are the diagonals. Everybody okay with that? Yes.
How can you figure out that UX plus XX equals
Because they're all the same. So here, look. Very good question. So I'm going to try to make sure I break that down for you. You with me now, right? So everywhere I saw a UX, I just, or RX, I exchanged for UX, and XT, I exchanged for XS. Yep. Good question. All right. That's a good proof right there, guys. Good proof. That was a little bit harder. All right. Now, let's, I'm thinking about leaving this for tomorrow. Rhombus. Oh yeah, trapezoids and kites are easy. All right, so let's do this. Let's practice this worksheet right here. And there's not even a proof. All right. I don't care about the landscaping problem. I don't care about that. But I do want you to be able to do everything else. All right. So you got 15 minutes. I think with 15 minutes, you should easily be able to get 1 through 12 done. All right. And then create a paper with graph paper and plot them and figure out using the slope and the distance formula, just what we did earlier, whether or not those are rectangles. Anybody have any questions? All right, I think that's a good job for today, guys. All right, that gives me a little bit of time tomorrow to finish up the rhombus and the square, and then the rest of the time devoted to the trapezoid and to the kite. Easy day. All right, my homeschool peeps. All right, just finish up this lesson right here, section 6-4. Just do that worksheet, knock that out for me. All right, then we'll finish 6-5 and finish 6-6 tomorrow. We'll review on Wednesday. We'll review the review on Thursday and then test on Friday on chapter 6. All right, guys, stay safe, stay healthy,
Bye. Thank you.
stay out of trouble.
Bye-bye.
Thank you. Bye.